Hello all. Here's a very quick video to demonstrate how we transpose formulas. Transposition is a very important skill to have for anybody that's involved with mathematics, such as scientists or engineers. Let's start with a simple formula. X plus 7 equals 10. Now I know everybody right here can see that x is immediately 3. But the idea is to use the simple equation to learn how the process of transposition occurs. When we're transposing formulas, the most important part of the formula is this equal sign, because that has to hold true all the time. So we use the theory, whatever we do to one side, we do to the other. So if we times that side by 5, we would have to times this side by 5 to keep the equal sign true. With that in mind, we can start chipping away at the unwanted variables on one side, making sure that we do exactly the same over this side. So in this equation, x is our subject that we want to get to, x equals something. So we need to get rid of the plus 7. Well, the easiest way to get rid of plus 7 is just to minus 7 off this side. So you've got x plus 7 minus 7 just leaves you with x, and those two cancels out. However, this equal sign no longer holds true until we minus 7 from that side. And now we've done the same on each side. We've got x equals 10 minus 7 equals 3. Basically, what we're doing is chipping away at all the unwanted variables on the side of our subject. In this case, x was the subject. If we have a plus, we minus, which means we do the opposite. If we have a times, we divide. If we have a squared, we have a square root. So a plus, we need to minus. A times, we need to divide. And a squared, we need to square root. And I'll give you an example of each. So let's jump to our next equation. 3x equals 15. Again, x is our subject, so we want to get rid of the 3. Well, in this case, the relationship with the x is that it's 3 times x. So the opposite of times is divide. So if we divide that by 3, and divide that by 3, doing the same on both sides, 3 divided by 3 equals 1, and 1 times x is x. So x equals 5. Let's try a divide. So we've got x divided by 3 this time equals 5. Again, the relationship between the x and the 3 is it's divided by 3, so therefore we do the opposite and we times it by 3. Again, we have to times this side by 3. The 3 divided by 3 equals 1, so 1x equals 5 times 3 equals 15. Let's jump into a slightly harder formula now, where we have x squared divided by 2 plus 4 equals 54. Now here we have a combination of all three, so where do we start? Well, generally we start chipping away at the variables that are furthest away from the x. If we try to do the 2 first, the 2's a divide, so we would times it by 2, but we're only timesing one part of this side by 2, whereas we'd times all this side by 2, so that equal sign would no longer hold true. So therefore we need to take away what's furthest apart, and in this case it's the plus 4. So if we minus 4 from this side and minus 4 from this side, well, 4 minus 4 equals 0, so they cancel out. Now we go back to our subject again and see which variable's furthest apart, furthest away from our subject. Well, in this case, it's the 2. The 2 has a relationship as the x is divided by 2, so therefore the x squared is divided by 2, therefore we times it by 2. Now we're timesing this whole side by 2, so we need to times this whole side by 2. However, if you remember your bed mass, At the moment, the equation's only timesing the 4 by 2, so we need to put that in brackets to denote that we're timesing that whole side by 2. Now they cancel out. Now we're left with x squared equals 54 minus 4 times 2. What's the opposite of a squared? Well, the opposite of squared is a square root. So if we square root x squared, they actually cancel out and we're just left with x. And we do the same on this side. And that will equal 54 minus 4 is 50, times 2 is 100, square root it all equals 10. So x equals 10. Applying the same theory to algebraic equations where we have no numbers, we just follow the exact same process. So let's walk through the examples. Again, a plus becomes a minus, a times changes to a divide, or vice versa, and a squared goes the opposite as a square root. So let's take a simple formula, x plus y equals z. And this is very similar to our first equation, x plus 7 equals 10. Well, in this case, we're going to make x the subject, so we want to get rid of the y. Well, because it's a plus y, all we do is minus y from this side. Y minus y leaves you with 0, but we have to do the same to the other side, so that becomes a minus y, so x equals z minus y. Let's move on to a divide or a times. Let's go x divided by y equals z. Well, again, we want to get rid of the y. We want to make x our subject, so we want to get rid of the y. The relationship's a divide, so if we times that by y, x times by y divided by y just equals x, and they cancel out. And so we times this side by y. So x equals zy. Let's just combine the two. So we've got x divided by y plus z equals w. And let's throw a squared in there. So now we're doing all three functions towards this. Well, again, as we did with the numeric transposition, we do the same with the algebraic transposition or the formula transposition. So we look at what's furthest away from our subject, and we want x by itself. So the furthest one away is the z. We can't get rid of the squared because we can't square root the whole side to get rid of the squared, and we can't times the y because we can't times the whole side by the y. But we can minus z, and we'll minus z over this side. Z minus z equals 0. Now we go to our next variable, and it's either the squared or the y. Which one's furthest away? Well, it's x squared divided by y. So obviously the y is furthest away, and if we times that by y, again, we times this by y, but remember our bed mass, we have to put that in brackets because it's all this times by y. Y times x squared divided by y, they cancel out, and we're left with x squared. So now we just need to get rid of this little squared. What's the opposite of squared? The square root. So x squared, square root, they cancel each other out. And if you don't believe me, imagine x is 10. Okay, so 10 squared is 100, the square root of 100 is 10. So they do cancel out. So now we've squared the whole side here, square root, we need to square root the whole side here. And we're left just to simplify it, x equals the square root, w minus z, y would be the correct term. That ends this small tutorial. I hope you've enjoyed it, and I'll see you in class soon.